Welcome to Algebra, Relations and Functions. The concept of a relation in mathematics is usually about how two sets of values relate to each other. But before we get too much into that, let's examine a couple of meaningful situations you can easily understand. Suppose there is a group of 8 students, ranging in age from 14 to 17. This means there are at least 2 students the same age. They are measured for height in inches, and the resulting numbers are shown on the right. A 14-year-old measures 50 inches, a 15-year-old measures 48. Another 14-year-old measures 60 inches, a 16-year-old 50 inches, a 17-year-old measures 55, another one 73, another one 70, and finally another 15-year-old measures 65. Notice there are 2 arrows coming from the age 14 value, 2 arrows from age 15, and 3 arrows from age 17. Only 1 arrow is coming from the age 16 value. This is an example of a relation, but not of a function. There is at least one age value that has multiple heights, and this fact causes this relation between age and height to not be a function. Here is another scenario you can easily understand. Let's suppose the 7 days of a particular week registered different high temperatures. Sunday registered 80 as a high temperature, Monday 75, Tuesday 90, Wednesday 85, Thursday hit 95 degrees, but so did Friday, and then Saturday 100 degrees was the high. This is a relation and it is a function. If you think about it, it is not possible for any particular day to have 2 different high temperatures. Now, notice that both Thursday and Friday have the same high temperature. This is okay. This is still a function. In a function, there can be 2 arrows from the left pointing to the same value on the right. There just can't be 2 arrows coming out of the same value on the left. Each value on the left can only have 1 arrow coming out of it. Pause the video and think about a real-life example of 2 sets of values that could be a relation but not a function, like the age-height relationship. Then think about a situation, again with 2 sets of values that could be a relation and a function, like the day-high temperature function. Discuss your ideas with a neighbor. Now that you have an understanding of these 2 concepts, relations and functions, let's dive deeper and look at more examples. Is this a relation? Yes, it is. There are arrows from each value on the left pointing to the values on the right. Is this a function? Yes, it is. Each value on the left has only 1 arrow coming out of it. The value 1 on the right has 2 values pointing to it, but that is okay. Is this a relation? Yes, it is. There are arrows from each value on the left pointing to the values on the right. Is this a function? No, it is not. There are 2 arrows coming from the 0 on the left, as well as from the 1. This breaks the rule for a function. For every value on the left, there must be 1 and only 1 value on the right. Another way of showing a relation is by creating a table. For each arrow you see in the diagram on the left, there is a row in the table. Notice the value 14 is listed twice, mapped to the value 50 and the value 60. 15 is listed twice, pointing to 48 and then to 65. By looking at the table, if you see any duplications in the left column, you can immediately tell it is not a function. Duplications on the right side are okay. Here is the table for this relation we looked at earlier. You can see no duplications in the left column, which makes it a function. The duplicate values of 95 in the right column are okay. In both of these examples of relations, see how there is 1 row for each of the arrows shown in the diagram? Look carefully to see how they match. In the left example, -2 maps to 18. 0 points to 1, 8 refers to -7, and 9 maps to 1. We determined this was a function. And you can see in the left column of the table there are no duplicate values. In the example on the right, you can immediately see this is not a function since there are duplicate values in the left column. Another way values in a relation are mentioned are as x and y values, the left column being x and the right column y. The x values are like input values into a process, and the y values are like the results of the process. If the relation is a function, it can be said that each y value is a function of the x value. You will hear this terminology quite often from here on in this course. Still, another way these relations can be represented are listing each mapping of numbers as an ordered pair, and then plotting them on a graph, as you can see here. In looking at this list of ordered pairs, you can quickly see that they represent a function, since there are no duplicate x values. In looking at the graph, we use what is called a vertical line test, starting with an up and down line on the left side of the graph, moving it across until we hit a point, and then see if it hits another point at the same time. If the vertical line never hits two or more points at the same time, the graph represents a function. And as you can see here, it never does, proving this is the graph of a function. In this set of related pairs of numbers, you can see duplicates in the x values, 2 zeros and 2 ones, and using the vertical line test on the corresponding graph, you immediately hit 2 points at the same time, not just once, but twice, on the 0 and on the 1 of the x-axis. This is clearly not a function. Let's look at some examples and determine if the relation shown is a function. How about this first example? Is it a function? Yes, it is. By looking at the x values, you can see no duplications. How about this one? No, it is not. There are 2 instances of 2 in the x values. This is not a function. How about this table? Yes, it is a function. There are no duplicate values in the x column. How about this table? Yes, it is also a function. Again, because there are no duplicate values in the x column. Remember, in the y column, it doesn't matter if there are duplicates. How about this mapping? Is this a function? The answer is no, because there are 2 arrows coming away from the -1. That is not allowed for a function. How about this graph? Remember to use the vertical line test on this one. Imagine a vertical line going across. Do you ever hit 2 points at the same time? The answer is, it is not a function. Yes, you do. The very last 2 sets of points are hit at the same time.